Friends, hello everyone. I want to tell you about a cheap alternative for the ground part. Right now, I am using the Orange P5 Plus. This is quite an expensive item, so it was decided to find a cheaper option. The board for video recorders is often discussed in the Telegram channel of the OpenIPC project. This is a board for recording video from IP surveillance cameras. If you look at it externally, it resembles an ordinary mini computer. It has a processor, memory, and basically that's it. Everything else consists of auxiliary components. It has two USB ports, a network port, and an HDMI connector, and the good old VGA connector for the monitor. A hard drive is connected to the board using a SATA cable, which allows for the recording of a large volume of information. There is also a connector for audio equipment, a technical UART port for firmware, flashing, and there are some other connectors about which I currently know nothing. There is also a battery and a quartz for the internal clock. I think we don't need this thing, so it can be desoldered. A 2 amp DC-DC converter 8A6T is installed at the power input, to which a voltage of 4.5 to 20 volts can be supplied. There is also a 220 microfarad 25 volt capacitor installed at the input. The processor is hidden under the heatsink. Let's take a look at the markings. I removed the heatsink and inside awaits the processor, Pi3536ERBC-V100. To be more precise, this is not a processor, but a chip that contains a set of electronic circuits based on a single crystal, including processor cores. Such chips are called SoCs, which translates to System on a Chip. According to the datasheet, the NVR system chip consists of 2 processor cores, one of which is responsible for NOTDIS video management, while the other is for processing and executing programs. It also features implementations of SATA 3, PCI Express 2.0, USB 2, USB 3, and HDMI ports. That is why we do not see additional chips for processing interface data on the board. Of course, there is hardware encoding and decoding of video using the H.254 and H.265 codecs. The chip system also includes the Mali T720 graphics accelerator with support for OpenGL and OpenCL. Let's see what the NVR can do out of the box. I connected one of the cameras. This is the Ingenic T31X. I hope a review will be released soon, and you can see how the NVR displays the image. The delay out of the box is significant, around 600 milliseconds. All menus are in Russian. An auto search can be performed. By the way, 10 channels are available. I have one camera connected, while the second one is offline. There is also a navigation menu. You can go to the main menu, where various settings are configured. For example, compression. Let's flash the firmware from the OpenIPC project onto the device. For this, I soldered to the technical UART port. I also connected a monitor, a network port, and a Wi-Fi adapter. Next, I launched the program to work with the serial port. Select COM6 and power on the device, and I immediately press the Ctrl-C keys to interrupt the boot process and access U-boot. Then I start the program. TFTP is needed to load the firmware onto the device. I'm checking what my IP address is. The following command sets the environment variables IP, adder, and serve IP. Then I create a backup of the current firmware. After that, the backup file should appear in the folder with the TFTP program. Here it is. You will need it if you suddenly get tired of playing with the OpenIPC firmware and want to return to the stock settings. I need to record the new firmware. For this, I go to the instructions and download the image. The file has a bin extension, but in fact, it is an image of the Linux operating system. It already contains system files and disk layout. I copy it to the TFTP program folder so that it can see it. I then sequentially execute the commands from the instructions. The only thing is that in the first command, it is necessary to set the IP address from the TFTP program. After the reset command, the system will reboot and the OpenIPC login prompt will be visible. Login, root, password 112345. I think now we can switch to another HDMI port to see if everything is working. And here we see a black screen and the OSD indicators, which are currently equal to 0. Now it remains to transfer the secret key from the camera to the NVR and configure the frequency channel. For this, I also connected the camera to the local network. Using the SCP utility, I copy the secret key from the camera to the device. After that, I can configure the Wi-Fi broadcast. I open the configuration file, and here I am interested in the channel. I set it to mine, which is 136, and I save it. After that, I open the configuration file of the video decoding program. And here I always make sure that the same codec is installed as on the camera. I changed the format variable to stream, although it later turned out that it would have been better to leave the value as frame. Here is what the developers replied regarding this parameter. In stream mode, parts of the frames are delivered as they become ready, while in frame mode, the entire frame is delivered. The first mode allows the use of slice technology. This involves dividing the frame into blocks. And if a packet from the block with the red color is conditionally lost, then only that area will not be rendered. In frame mode, an entire frame is lost. However, frame mode provides lower latency on the standard RTP stream. Here, I set the resolution and refresh rate of the monitor. I turn off the OSD because I do not use it. I save the settings and reboot the device. And now the image has appeared, but it's not clear. I don't know what the reason is. I will find out now. I struggled with the problem for about 15 minutes. At first I soldered the USB cable directly to the NVR, and everything started working. I thought the problem was that I needed to make a certain twist, but the issue turned out not to be that, but rather a faulty USB cable. I had this short cable, and I replaced it with the one that came with the Wi-Fi adapter, and everything worked. Here is the camera looking at the aquarium, and the monitor shows a transmission delay of about 240-250 milliseconds. The delay is very high over Wi-Fi, so I am conducting the test via cable, measuring the delay for the 2165 codec. Thus, for the quality of the experiment, I am currently using the Orange P5 with a screen resolution of 60 Hz and the 265 codec. The delay in the RTP protocol is understood. Now, let's install the Wang firmware on the camera, which uses the HiSilicon SDK for encoding, allowing us to replace the multifunctional Majestic with a simple open source program. By the way, the firmware only supports HiSilicon and Goki cameras, versions B200 and B300. On the IP camera, I open the file etc. OS release, which indicates the current software versions, and I replace the value of FPV with Wang. Now it is enough to invoke the sysupgrade command to download the necessary files and write them to the camera. You need to call with the keys K and R. Done. Now you can log into the camera. Login is root, password is 12345. The PS team will check that we are using Wang instead of Majestic. Here is this line. Next, I open the Wang settings file and specify the IP address of the NVR. This is needed for testing the delay over a wired connection. If you have a Wi-Fi broadcast, then we leave the value as is. By default, I restart the service making sure that Wang has started with the required parameters, in this case with my IP address. The video is currently being encoded using Wang. I immediately noticed that the image appears somewhat enlarged, but there are practically no lags or delays at all. What struck me the most is that the delay is constant. Right now, for example, it's 134 milliseconds, and it doesn't fluctuate. Even when the delay varies, the values are practically the same. Interesting, the same 265 codec, but with a bitrate of 7 megabits per second. Previously it was 4 megabits. The resolution is HD at 30 frames per second. I launched the camera with Wang in RTP stream mode at 720p 60 frames per second, and we are trying to measure the delay. The delay is approximately the same as on the NVR, but there are fluctuations. I am currently measuring the delay with the Wang frame RTP parameters. The delay check at 144 Hz is approximately around 100 milliseconds, as stated. As previously mentioned earlier, the NVR supports the VGA connector, and I found an old monitor with a VGA output in the storage cupboard. I connected the VGA and HDMI cables, and now I am currently supplying power, but everything turned on. The image on the VGA monitor is slightly compressed, because I probably need to adjust the settings. We will do that now, and I have a second display connected right here. Everything is excellent. It displays as it should, with almost no delay, but about 130 milliseconds as we have measured. The screen resolution is changed in the configuration file in dic.conf. I changed the variable mode to the required resolution and save it successfully. Now the image on the VGA monitor displays without distortion, while on the HDMI monitor, it appears in a small frame. I don't know how to fix this for now. Perhaps there is no way.
Would you recommend coming on Saturday? I hope so, because I will be waiting for you. Seriously, did you remember the next stream on Saturday? Leisha is speaking now. It was absolutely divine. I will do it this way. That's it. See you soon. Bye-bye.
I think we'll wrap it up here. I hope the review was helpful. If you have any questions, feel free to ask them in the comments under the video or in the Telegram chat. All links are in the description. Don't forget to like and subscribe. Goodbye, everyone.